we will look at how to convert fractions into decimals. Now in general, there are two steps to convert fraction into a decimal, right? The first step here is to set out the fraction as decimal division, okay? Remember, fraction is, for example, 2 over 5, right? So we set it out as a decimal division, dividing the numerator by the denominator, okay? So this is the numerator, right? Numerator, and this is the denominator. So we will set out the numerator 2 divided by the denominator, okay? So that's step 1. Step 2 is you attach enough trailing 0 to the numerator, okay? Right? For example, 2 here, 2 is not enough to be divided by 5, so you need to attach enough 0 here. For example, if you attach one more 0 behind 2 here, and not forgetting 2, there is a decimal point behind 2, so the decimal point stays the same. Okay, so in this case, we consider the whole 2 number here. We get 20 divided by 5, right? So that makes the division possible. Okay, so once you do that, you will continue dividing until you find the answer is either terminating decimal or repeating decimal. There are 2 cases to consider, right? So we will look at the cases one by one. So what do we mean by terminating decimals? That means the division will work out evenly, right? So go back to our example earlier, 2 over 5, right? So to do that, I get the numerator divided by the denominator, and I know that 2 is equivalent to, like, there is an invisible decimal point behind 2 here, and 2 is not enough to be divided by 5, so I need to add one more 0 behind, so that will give me the decimal point here, right? So now I consider 20 divided by 5, I get 4, right? So 20. Now 20 is divided evenly by 5 and get 4. In this case here, my answer will be 0.4. So there will be no more further steps here, okay? Because it's divided evenly. Now in this case here, we know that this is equivalent to 0.4, and this is what we call terminating decimals, right? Terminating decimals. Let's have a look at one more example. If you have 7 over 16 here, so this is equivalent to 7 divided by 16, right? So we know that 7 cannot it's not enough to be divided by 16, so we add one more 0. So the moment we do that, we have a 0 here, okay? 0 point. Now we consider 70 divided by 16, right? So we get 4, and we shall get 64, right? So then we subtract 64 from 70, we get 6 here, okay? Now see, 6 here, we need to continue the division further, right? Now the way to do this is to add 1 trailing 0 behind 7, right? So this trailing 0 here, we pull it down, so we get 60, right? So once we get 60, we can divide by 16 3, okay? And we get 48. Then we divide, so we get 12. Now 12 here, we need to continue division again, right? So the way to do is to add one more trailing 0 behind and pull the 0 down, so that 12 now becomes 120, and 120 divided by 16, we get 7, right? So we get 7, which is 112 over 8, right? So again, we put one more trailing 0 and pull it down here, 80. So in this case here, 5, right? Give us exactly 80, and we have no more remainder, right? So 7 over 16 is equivalent to 0.4375. Okay, so sometimes for terminating decimals, you have to work a few more iterations, right? You have to add more trailing 0 behind, right? As in the case here, right? Continue until you can divide it evenly. Next case, we look at repeating decimals. This is the case when we cannot divide evenly, okay? Right? What this means is that the division will go on forever. Let's have a look at one fraction, okay? So we want to convert this fraction into decimal. We get 2 divided by 3, right? So 2 cannot be divided by 3. We need to add one more trailing 0 here, right? So 3, then we look at 2, we make 2 into 20, so 20 divided by 3, we get 6, which is 18, and we left behind 2, right, with minus 2 here. So add one more trailing 0, pull it down, we get 6, 18, then divide, get 2, one more trailing 0, 6, 18. I think you can see the pattern, okay? You will always have 2 as the remainder, and it will just keep on forever, right? In this case, we can represent the overall answer by 0.6. Sometimes we can represent the repeating 6 behind by a bar here. So that means 0.6, there is forever 6 repeating. Okay. Another way is we may leave it in terms of the number of decimal places. For example, if we want to leave it as 2 decimal places, right, 0.6666 forever. If we want to leave it as 2 decimal places, still remember how do we do that, right? We look at the divider for 2 decimal places, and then we look at the number behind here. This is more than 5, so we have to round it up. Okay, so then 2 decimal places, we get 0.67. Okay, 2 decimal place, right? So that is the 2 options that we have. Either we use a bar to represent that this digit 6 here is repeating forever, or number 2, we round it up to the appropriate number of decimal place, right? So another example, 5 over 11, for example, so which is equivalent to 5 divided by 11, right? So if we do the division here, we will find that we get 4, which is 44, and left behind 6, and then we add trailing 0, and then we get 5, get 55, minus 5, and then trailing 0, we get 4, get 44, 6, and then 0, 5. So you see that instead of one digit as in 6 here repeating, we get the pattern of 4, 5, after that 4, 5, after that 4, 5, etc. So how do we deal with this forever number? Again, we can use these 2 methods here. Now, for the first step here, we can write 0.45 and then a bar over 45. So this means 45 is repeating forever, right? Another way is we round it up to the appropriate number of decimal places, right? So for example, if we want to round out to 2 decimal places, 0.4545, 2 decimal places, then the answer will be 0.45. But we must indicate that this is 2 decimal place, right? So that's how we convert we convert a fraction into decimal.